We are going to start here with Chapter 21, Problems 76, 77, and 12 from the first two nights' homework from your Electricity and Circuits PQs packet. Number 12 is asking about the potential difference between a bird's feet when he is standing on a copper wire. So at some point we are going to use V equals IR, but first thing we need to find the resistance of the wire, and in order to do that we are going to need our givens and the resistivity value of the wire, which is rho. Since it's a copper wire, you have to look in your book and see that it has a value of 1.68 times 10 to the negative eighth. The length of wire is 6 centimeters, so 0.06 meters. And then the area that they tell you is that the area between the bird's feet has a cross-sectional area of 0.13 centimeters squared. The trickiest part for this problem is probably this conversion. Don't forget when you've got centimeters squared, if you want centimeters to cancel in your denominator there, you have to square the whole denominator, and then that is equal to 1 times 10 to the negative 2 meters, and you have to square that numerator as well. So what you end up getting for your area is 1.3 times 10 to the negative fifth meters squared. From there, we can go ahead and get the resistance of the wire, which is rho times L divided by A. So we get 1.68 times 10 to the negative eighth times the length of wire, 0.06, divided by the area, 1.3 times 10 to the negative fifth. And we get a total resistance of 7.75 times 10 to the negative fifth ohms. Now from there, we can use Ohm's law, V equals I times R, to get the potential difference between his feet. So the current they tell us is 32 amps times the resistance we just found. And you should multiply across and get 0.0025 volts as your answer. And in B, they're asking, will your answer to part A increase or decrease if the separation between the bird's feet increases? So what they want to know is if the distance between his feet goes up, so there is a greater area, a greater length of wire between his feet. Notice that the length and the resistance have a direct relationship. So if the distance increases, that means resistance is going to increase. Therefore, if resistance increases, that means your voltage is going to go up, and that would be the answer for that one. Alright, next one, 76, is talking about a portable CD player here. Switch pages. So it says a CD player has a certain current at a certain potential difference or voltage. How much energy does it use in 35 seconds? So this is number 76, part A. Let me make sure you can see that. There we go. So energy is always going to be power times time, and power is current times voltage. So what you end up getting is energy equals IV times T. So the energy is going to be the current that they give us, 7.5 milliamps, so 7.5 times 10 to the negative 3, times the voltage, which is 3.5, times the time that you are using it. It's already in seconds, so you can leave that as 35, and you get 0.91875, and your units here are watts times seconds, which is the same thing as a joule. So 0.91875 joules is part A. And then in part B, they want us to know, suppose the player has a certain mass, what length of time could you run it, or could the player operate on the energy required to lift it through a height of 1 meter? So now you've got to think of way back when we talked about power and mechanical work, and power is the work you can do in a certain amount of time. So the power that this CD player has is just I times V. It's going to equal work divided by time, where work is force times a distance. So what you are going to get is your current, 7.5 times 10 to the negative 3, times your voltage of 3.5, whoop, that's over time, equals the force, which is the weight of the CD player, so it's mass 0.65 times 9.8, and you're lifting at a distance of 1 meter, divided by the time, and you can go ahead and solve for the time to be about 242.7 seconds. And last one from this series of videos will be number 77. And it says a heating coil is immersed in water, kind of like your lab. The coil has a resistance of 250 ohms, and it warms the water to 32 degrees Celsius in 3.5 minutes. What is the voltage across the potential difference that the coil operates? So your idea here is that the electrical energy that the circuit has warms up the temperature here. So we are going to say that the energy of the circuit equals the heat gained by the water. And so the energy of the circuit is going to be power times time, and the heat gained is going to be MC delta T of your water. So the power, according to the variables they've given us, the voltage and the resistance, is going to be V squared divided by R. So we are going to take V squared divided by the resistance of 250 times the time that you are operating it, which is 3.5 minutes or 210 seconds. And that's going to equal the mass of the water, 4.2 kilograms, times the specific heat of water, 4,186, times the change in temperature, which is the difference between 32 and 22, so 10 degrees. And you can go ahead and solve for the voltage or potential difference to be 457.5 volts.